Dear participants, so we will be starting the session once the speaker has been joined. So you can take a small break now, and you'll be intimated once the speaker is joining. Even in the WhatsApp, we'll be intimating you. So kindly stay connected. Thank you. So it's my great pleasure to introduce today's distinguished speaker, Dr. Rajat Shinde. Dr. Shinde is a computer scientist at NASA Impact UAH, currently based in USA. He recently defended his PhD in geoinformatics from IIT Bombay, where he carried out his research under the Geocomputational System and IoT group in the Center of Studies in Resource Engineering. His academic contributions are commendable, with several conference papers, journal articles, and book chapters published in renowned international platforms. His research interests span multiple cutting-edge domains, including 3D computer vision, machine learning, embedded system, Internet of Things, high-performance computing, and signal processing. Dr. Shinde's PhD work focused on 3D lidar point cloud reconstruction and classification using compressive sensing technique and deep convolutional network. His work has significant impact as lidar point clouds are now crucial for Earth observation, forestry, urban mapping, autonomous navigation, and many other emerging applications. His master's research also explored the application of deep learning for onboard point cloud processing, pushing the boundaries of real-time and high-performance geospatial analytics. With his rich expertise and hands-on experience in advanced computational technologies, we are honored to have him with us today. We are truly delighted to welcome you, sir, who will be taking us through the fascinating and rapidly evolving domain of end-to-end Geo-AI from model design to real-world deployment. Sir, your presence adds an immense value to this FDP, and we are eagerly looking forward to your session. Once again, we welcome you, sir. Over to you.
Uh, Thank you very much again for the kind introduction. I'm not sure if I'm worthy of such a big introduction. I don't have that much achievements, but yeah, I appreciate all the kind words and thank you for all of you to be here. I know it's 7:30 in the evening, so it's the time when most of us are off to our own activities. But yeah, I'll be talking about end-to-end GeoAI workflows today. I'll go ahead and share my screen. Uh, Dr. Iyer, can you see the screen? Can you please confirm that?
Yes, sir. It is visible.
Okay, thank you. So should we start?
Yes, yes, sir.
Okay, I would like to keep it as interactive as possible, even if I understand it's a bit late according to Indian time. But I like to talk to people, and if there is anything with which we can discuss or we can interact, that would be great. So I'll be talking about end-to-end GeoAI from model design to real-world deployment. And these are some of the works which I have been part of across multiple projects, across multiple experiences over the last 2, 3 years. All the things which were mentioned in the introduction are somewhat left behind, the embedded AI and all the different projects. But now I am moving more towards data-centric AI and how geospatial data can be leveraged to develop robust and responsible systems. I am not talking about models, but I'm talking about systems, and that is what I'll be emphasizing. I am aware that we all are quite experienced in building models, and also we are aware of how deployment or inference happens. But I'll focus more on data part and how data engineering makes it more worthy of our contributions. Because data was there 20 years back, and it is going to be there 20 years after as well. Models keep on evolving, models keep on iterating over the time. So with that, uh, I'll quickly mention a bit about myself. I did my I'll skip the education part that was already covered in the introduction, but currently I'm working as a data science lead for ESA NASA Multi-Mission Analysis Platform. It's a cross-collaborative platform which was developed some 5, 7 years back, and it helps the user working group and scientists to do all kinds of biomass research. It's a cloud-based platform. And I'm also a member of the AI for Science project community, which involves research to operations of foundation models, including the Earth observation one and weather and climate one. Uh, Nowadays, we are focusing more. I'm particularly focusing more on how these models can be operationalized in production setting, and including red teaming, the pre-processing, post-processing, and inferencing workflows. So I'll be mentioning some understanding from this project. Apart from this, I also lead Earth 2 or Earth 2 as a digital twin working group under Earth Science Informatics Technical Committee for IEEE GRSF. And if you are interested in any of these activities, please we can collaborate and send an email to me, and I'll respond back with more details. Currently, I'm serving as Vice President for OSGeo Board of Directors. OSGeo stands for Open Source Geospatial Foundation. Uh, and I'm up for election this month, so probably this might change. But OSGeo also has given a lot of experience in terms of taking things or software from your own laptop or your own system to a production setting. Uh, Okay, with that, I would focus on three research problems today, or three problems which we usually incorporate in the current Geo-AI workflows. At any point of time, if you feel that you have any question, or please note it down, we can have a discussion at the end. I don't have the full time which was allocated to me, so it will be great to have more discussion, and I'd love to answer your questions to extent. I The first research problem, which we all are aware of, is the data related or data set related problems. So with GeoAI workflows and with GeoAI systems, we need to have data sets, proper, responsible, and robust data sets. Datasets are not something which used to be in our conventional machine learning algorithms, where we used to have, snapshot of data. We used to download a couple of files along with their labels, train the model, and then use those results. Nowadays, dataset is constantly iterating. It changes with each transformation, with each user. So, for example, the original source data set, which is, let's say, an example of Sentinel-1 or Landsat data set, we take it, we annotate it for our own use cases, different users, and then we prepare our own new data set. So, from Sentinel and Landsat images, we can create data set for segmentation, we can create data set for classification based on what annotations we are using. And the moment we annotate or we transform these data sets, it becomes a new data set. So whoever is doing that transformation is its responsibility to talk about all these things, which are the problems related to data. So that is where responsible curation with metadata and provenance comes into the picture. If you are following the responsible AI circle, you might be coming across these terms, provenance and lineage. Public repositories like Hugging Face and Kaggle, they are also putting a lot of efforts in implementing provenance and lineage in this. In simple words, consider it as a GitHub where we used to put our code and we used to do versioning with each new release. Similar to that, we can do it with datasets as well. With each passing on a new version or a new transformation, we can store that information, and we should store that information as a part of dataset. That's where the provenance and lineage practices comes in. So provenance tells you from where the data originated and how it is in the current state. The second part is AI-ready datasets and including the cloud native and cloud optimized formats. And this has become very important with respect to the cost which is involved while storing these datasets. These datasets are pretty huge, and I'll show an example in the next slide as well. Label quality and co-registration along with the quality masks. So when we are deploying these systems into production setting and you must be aware, and you should be aware with all the laws which are coming around deploying these AI ready systems in production setting. So even if we are using these, for example, insurance company or a crop insurer is using any of the Earth observation models for directly estimating the insurance amount, then it's the responsibility of model developers to have a model which is accurate and precise and reduces the uh, issues coming from false positives and false negatives. It also includes that our data set, which is being used for modeling, is a representative and balanced data set. It has all the bias check done and bias mitigation has been performed before developing the model. So there is a very good reference known as data cascading, which tells you about if there is issues in your data set, how bad your model can be and how bad the model outputs can be. The second parallel is with the models. We all are aware, we all develop our models on day-to-day practices. Models is a general term, but this can be any algorithm, anything which is relevant to using the data set and automating its processing. So there are foundational models which are coming in. World models is the recent terms which is coming in. But the challenges which are associated is basically infusion strategies and how these processing can be done over a scale. So if you have to process the entire data set over a scale, what are the best practices there? Challenges are in efficient training and fine-tuning workflows. So with the foundation model, this fine-tuning workflows is becoming very important because we can take the pre-trained model and use it across different downstream tasks. Then robustness and uncertainty estimation. It is very important to provide your confidence in the model output. That's as I was discussing with examples such as crop insurance and others. And metrics, the performance metrics which changes with each evaluation. Within or between these parallels, there is another important thing which is deployment, which is kind of engineering task and it helps a lot in end-to-end project analysis. So I'll cover some of these, and then in the end, we will see what are the best practices which are happening around the deployment and inferencing part. So even if once your model is developed and you have it saved in your system or in any public repository, it takes a lot of effort from there to ship it in a production or deployment setting because you have to think of problems related to how these models will handle new data sets or how these systems will handle new data sets. So there comes the concept of containers and workflows. Then you need to think about scalability. If 10,000 or 15,000 users are using the system at one go, these systems are resource heavy, right? They need GPU at the back end. So if 15,000 users or 20,000 users are putting request over a big bounding box for processing and getting the output, you need to come up with modern day solutions because you cannot expect a user to select a bounding box and wait for 10-15 minutes to get the response. So in that way, we need to look into caching mechanisms. We need to look into streaming options and tiling options so that your image gets rendered fastly. Whatever output you are having, you can, from a visualization perspective, you can overlay it with the original image and see what results you're getting. So this also calls for ML ops. ML ops is machine learning operations, workflows, and tools which are coming to, which are getting famous to understand drifting and retraining and versioning part. So as we were discussing, each new data set is a new version. Each model will be a new version, but your new system will also be a new version. So, and all of these are combinedly comprising of a system. And on the governance side, we are interested in doing the cost benefit analysis, doing the security compliance. So, if I'm asking a question to a chat GPT or any of the virtual assistant or Gemini, it shouldn't be something like which, violates the content moderation rules. We all are seeing image generation models. Everybody is using these models for generating their figures, illustrations, personal images, but they should not violate the basic human principles. So we need to do safety and security compliance as well. And the AI-based safety analysis and risk analysis is a very hot topic as of now. So we talked about these parallels, but somehow these are all connected. And when you do this in a system setting or in an end-to-end workflow setting, there are in between bridges which needs to be discussed as well. And to follow or to solve these issues in a standardized way, it is very important to use standard practices or practices which everybody is using and reviewing. So reviewing is an important part of this entire workflow. Now from here, let's shift a bit to cloud native processing system. And that is where it allows us to have all of these end-to-end Geo-AI workflows. So right from data preparation to model development to deployment, everything can be done these days on cloud. And what it provides is with the cloud, you have the option of constantly uh, doing the processing without any hindrance or without any break in resources because cloud is out functioning most of the time unless there is a failure in the service providers. But it's a complete cycle and anybody can access it. It follows a fair principle. You can find most of the things, you can share most of the things which are running on the cloud, right from your data set, right from your algorithms. So it has three aspects, which is most of the digital infrastructure is using these three aspects to cloud native processing. One is definitely the cloud native geospatial data, then the computing part, which includes all the infrastructure and hyperscalers which are coming in. So these are containers which can be used for running the end-to-end workflows. And then there is the automating AI workflows when you have to parallelize things. So OpenShift and similar softwares are there, which will allow you to do all of these, like storage, data stewardship, metadata management, in a single platform. And then there are standards which allow you to talk between these tools. And these standards are like training data markup language. I'll be talking about one standard which we are leading in terms of development. So, with this, let's move into chapter one, which is AI ready dataset. And I'll quickly talk about what AI ready dataset means and how do we reach from a couple of files in our laptop or system, which is TIFF files, or let's say any of the files, along with their label and uh, along with their annotations to a AI ready format, which can be used for the processing. Just confirming once. Am I still audible?
Yes, sir.
Are we
Yes,
all
sir.
on the same
Yes.
page?
You're audible.
Okay, thank you. I'll continue. So this is a slide which we usually use to explain the amount of data set we are capturing. And this is the operating and future science fleet. Uh, this is from NASA perspective, but we are all aware of all the science fleets which are happening. You can see this is the amount of data set which we are capturing. And this is the amount of data set which we were capturing only from Earth observation perspective, starting 2023. So we can see there is NISAR here as well. There is Landsat. All these data sets are here. And the scale of geospatial data is increasing day by day. It is not only increasing collectively, but it is also increasing in a particular mission or a particular project, including the amount of data set which we are going to capture with these Earth observation missions. So this is a small piece which was published in Earth Data, and I was reading through it. It mentions that NISAR is expected to generate a data volume close to 85 terabytes each day, and it should lead to somewhere around 140 petabytes of data over a 3-year mission. Now, this is a lot of data, and just a quick comparison to understand, 1 petabyte is equivalent to 20 million 4-drawer filing cabinets filled with text. Now, it's very important to uh, understand the scale here because we are not only talking about having this data, we are talking about having this data set, processing it for each of our use cases, and then developing models on these big volume of data. And each of this data set or each of this transformed data set after processing, after modeling, will be stored somewhere. So that's the amount of storage we are expecting. And with this, it's our responsibility to have, responsible and reliable approaches for getting the data and processing it. Now, let's move on to challenges in conventional GIS data processing as well, because a lot of these studies will not only involve the data set which are available like this, but we will also have on-the-fly algorithms to get data from our existing sources, because most of the time we have to do analysis like this. So this was a study which was done as comparing cloud optimized formats versus current formats which we typically use. So like NetCDF and GeoTIFF, which are the usually used formats. And based on criteria, they were scored in terms of what are the better options. But in this one, if we'll see, uh, point cloud is there, in situ data is there, airborne data, vector data, and values are there. So with the conventional geospatial formats, the NetCDF and GeoTIFF, we are missing a lot of facilities which can be there in terms of support. But with Parquet and cloud optimized GeoTIFF, so if you are using Hugging Face by any chance for any of your project, they use Parquet file format. GeoJSON and HDF5 in the cloud, they offer some of these facilities to improve the data access. With that in mind, when we collaborated with ML Commons, which is a consortium of developing all of these standards, and we worked on a standardized metadata format. I'll present the demo on it as well in the end. But we worked on Croissant, and Croissant is a standardized metadata format. So it helps you to store metadata in a human and machine readable form. So for any data set, and it was targeted towards AI ready data set when it came out into the existence. But with time, it is now supporting vocabularies. It is now supporting uh, existing data sets which do not have AI ready applications directly. So in AI/ML ecosystem or artificial intelligence research and development ecosystem, if we see from a user perspective, we are mostly interested in three applications, which is searching, downloading, and loading the dataset. And from a creator's perspective or a producer's perspective, we are interested in creating a new dataset. So to address these things, Croissant was designed on these four applications, and its tight integration with all of these helps you to develop workflows which can run end to end. So, for example, it is integrated with Google Search and other search-based engines where you can search for uh, the datasets which you want for your research. It is integrated with download option. So you can directly download any of the metadata in JSON file. And since these are JSON files, these are very small in the size. Then you can directly load these JSON files into your PyTorch or TensorFlow workflows. So what happens with this is when you are loading any of these JSON files, you don't need to download the dataset on your local machine. It can directly read it from the DAC or wherever it is stored as a form of array records, and those can be passed on to your data loaders and models for training. And if you're on a producer side, you can create your own croissant data and publish it on Hugging Face or Kaggle or Dataverse or here. So this is the overall architecture. Now, when we launched this along with the entire community, we understood that the domain-based requirements are different. So the geospatial domain have different requirements for metadata. Health domain has different requirements for metadata. So based on this, we proposed GeoCroissant, which is geospatial extension. It is about to be launched in a couple of months. But what was the need behind it? So I'll quickly skip through these slides. We all are aware of it. So basically, the consistency and integration of all the Geo-AI datasets which are there, and typically we will use the data portals which are available in Geo-AI domain, but they lack integration in terms of how this can be directly used in your optimized workflows. It is still the same conventional practice where you are downloading the data and passing it on to your data loader in your local machine. I'm not saying it is wrong. I'm just saying it is not efficient. And that can be improved with such workflows which we are discussing using Croissant or OGC's training data markup language or Stack. The next thing is the data quality and model training part is not discussed. And in an end-to-end workflow, this can be done if you are storing this metadata in your dataset format. So this is early times in research when we are talking about responsible GeoAI, and early times are good times because that bases the foundation for how that will happen in the future. Now, and yes, yeah, the Earth observation data sets are complex in nature. It is high dimensional. There are multiple information which are covered across bands. There is spatial and temporal dependencies. The data volume is very big, and we have issues coming from data quality, like cloud cover is there, or gaps are there in the movement or maneuvering of the platform. Uh, the heterogeneity is also there. There are different types of data sets, different types of satellites, in situ observations, which are point values coming in. There is vector data, which we use from our own use cases. And scale variability, the geospatial data can be present in local to global scale. Our analysis can vary for a single problem on a local to global scale. We are not at that edge as of now, but privacy and ethical concerns are also being introduced across using geospatial datasets with very high resolution images coming in centimeter resolutions. It's very widely evident that these images can be used for violating these concerns. And the overall Earth system as a system has a lot of variable dependencies in terms of how you can, process or do the digital analysis of the Earth system. Many a times, what we are seeing cannot be uh, validated from our processing or analysis. So I'll skip this part. We are all aware of how different kinds of geospatial data looks like. There is street view imagery, there is LiDAR data, there is multispectral images, there are buoys or sensors, which are point values, and all of these has geospatial aspect to it. And all of these geospatial data sets can be used for doing any kind of analysis and processing on its own as an independent data set or involving the data fusion practices. So when we were proposing Croissant, and but before that, Croissant is based out of schema.org. Sorry, I'll just take a short break. So Croissant is based out of schema.org, and schema.org is a very big vocabulary which is already available schema, and it has most of the properties which can be used to define metadata. Uh, it has some unique characteristics which are relevant to geospatial domain as well, which are available, and some of those are not available. So when Croissant as a format was introduced and launched last year, it was missing some of the geospatial attributes, and that is where we found out that okay, we can have some geo attributes which can be useful for this end-to-end processing. And in that, we did some research, we did some interviews with people who are in this domain, and we took their opinion about what characteristics we would need to have in metadata for storing these data sets responsibly. So as you can see, some of these are responsible AI related attributes, like citation and where the data set is coming from, what's the provenance of it. And some of these are geo related attributes like temporal coverage, geospatial geometry. Is it a polygon based, or is it a well-known text-based geometry? What's the shape of the particular annotation? If we have this annotation or this metadata in a textual format, it becomes easy and fast in terms of processing, because ultimately text is the language where humans and machines can combine. Uh, Humans and machines can talk to each other in textual format very easily as compared to other modalities. So that's the idea of bringing the entire metadata in standard way into these representations. So GeoCrusoe has it covers the spatial reference information which is originally missing in core Crusoe. It can support nested data, which is very much important for geospatial datasets, and it also supports interoperability with existing cloud native geospatial data formats. The biggest thing which I like in such kind of implementation where you have metadata based workflows is data fusion opportunities. So a lot of geospatial data makes sense with other tabular or structured data sets. For example, if I want to understand how much temperature is increasing over the Thane region in Mumbai, so I'll use the census population across Thane region. I'll see what is change in population happening, or what is change in industrial expansion happening. These data sets are usually in tabular formats, but along with this, I'll also do an analysis for the data set which is giving me climate indicators or forestry based indicators, or urban analysis, which is the geospatial part which we do. Now, if we have to combine all of these, up till now, the conventional method used to take a lot of time still in data processing and data creation. But now, if you have metadata for both of these two different applications, you can just combine these and merge the files, because these are text files and JSON LD based files, JSON linked database files, and can be linked easily. This is an example of harmonized Landsat Sentinel dataset, which is a flagship NASA dataset of known as HLS dataset. So in this case, if you'll see, all the files which we want to use are stored as the encoding format image TIFF. These are source images, and then you have source annotations which can be used. Those are also image TIFF. You have mask and you have merged files. So TIFF and TIFF. Now, when you are loading this into your data loader, you just need to load this JSON file. This is an example. There will be a full JSON file, and that can pass on to your data loader. And once your data loader is ready, you can run the algorithms and move on to the deployment part, which is the last step of this. Okay, so chapter 2 is models. But before moving, I like to do a quick check. Is everything all right? Are we all on the same page? Any questions up till now? Uh, uh, am I still audible to everyone?
Yes, yes, sir, you're audible. Everything is all right, sir.
Okay, I'll go ahead then. Thank you, ma'am. So, chapter 2 is about models. Models are always the attention-seeking part of the entire AI ML ecosystem, and we all are very much excited about developing our models, doing the processing. Uh, in Geo-AI domain, and uh, since I was talking about models, I am not going to spend a lot of time on models because modeling is a bit evolved over the timing, and earlier we used to do the conventional processing using SVM or random forest-based approaches, where our focus was to not do it over a large scale, but do it mostly in terms of understanding how some information can be learned from data in an automated way using algorithms and workflows. Nowadays, the foundation models, with the emergence of foundation models and other large models, the terminology in modeling has changed a bit from pre-training and fine-tuning and inference-ready models. So when we talk about pre-training, it basically means the earlier feature set which we were used to learn from SVM or random forest-based models. Those features can be directly learned with large stack of deep layers and the transformers based architecture or these foundation models. They learn that those feature set for you on a broad task, such, for example, reconstruction or something like that. And those feature set then can be used in your own custom based models like UNet or ResNet, or even for random forest based approaches. In case if it is not working directly, you might have to do fine tuning. So these tasks then become downstream tasks uh, from coming from a pre-trained foundation model. So typically, a foundation model is trained on a common general task such as reconstruction. But then the downstream tasks happen, which is like land cover or disaster mapping or burn scar segmentation or landslide analysis. Once your fine-tuned model is ready or the pre-trained model is ready based on what you are going to do, you make it inference ready, and inference readiness involves the test time scaling, which are current industry practices, or optimizing your models because if these models are big in size, they are billion parameter or million parameter models. So how you can compress these models to be used and stored in less space, how you can do scalable cloud or edge deployment. So, for example, if you need to deploy these models in an edge-based setting, what kind of optimization you need to do, what kind of connection you need to do from model to data loader part. And then there are task-specific models as well, which we custom build, something like CNNs or transformers. And then we will fine tune it for our own use cases for hyperspectral data set, for LiDAR data sets, something like this. So this is the current state of Geo-AI models, and I'll quickly share what are the best practices here from my understanding. And definitely it covers somewhere around the review and auditability aspect, which I was discussing earlier. So if we have version datasets and metadata, it becomes easy to trace where the error is happening. And even from a data perspective, if you have a model and if you're using metadata along with each data sample when you are training the model, you can look back to your data sample and find exactly which data sample is an outlier or which data sample is hampering the model's accuracy. This is something which we typically miss, but with metadata and these new workflows which are coming across, nowadays this is considered as a best practice to understand. Then sharing weights and code is the reproducibility part. I'll not go into that. We are all aware how important that is. Documenting pipelines, and this again helps in the overall system-based structure when we are working in an end-to-end workflow. So exactly we can document which step is causing time in terms of implementation, or which step is causing failure in terms of analysis. So if you are running it as a job, we can constantly use the logging information which is coming from that job and understand where we are finding any failures. In terms of fairness, like using benchmarks and holding out splits. So if we are using a big data set, we can use benchmarks across different models, do ablation studies, as well as we can keep on one the gold set or the training set, the testing set, which can be used for checking if the model is performing fairly or not. It's good to perform uncertainty and robustness analysis for reliability and um, to understand if the model is in confidence of its results or not. Publishing model cards and publishing data cards is something which is good for transparency. And in your submissions for conferences and journals as well, we all are aware of it, I'm pretty much sure. But these days, a lot of emphasis is being given in terms of checklist for a lot of these paper submissions. If there is the weight is shared or not, or the code is shared or not. And pre-trained using pre-trained features is also good from coming from foundation models because they kind of incorporate a lot of information coming from these data sets. And in stability, when we are talking about stability, applying continuous integration and testing is a part of it, which the entire community anyways does. So testing is something which we all do for because we need to use these models in our own experiments. But with this, what kind of issues we avoid? We avoid the reproducibility gaps. We avoid the data drift. So if data set and metadata is stored, we at any point of time we can quickly tell that okay, this is how the original uh, data was transformed into this part and what how the drift has happened. So if I'm getting results which are not consistent with the actual model, we can have a look into it because these models are deterministic. I am not talking about any generative models. So there is not new information which is coming in, and deterministic models should give same output if the data is not changed at any cost. It avoids the opaque workflows. It avoids biased evaluation. We do not put unreliable models in production setting. We get rid of the low transparency or high compute cost because any operation which you're performing on the cloud, which is the usual practice these days, can incur you a cost. And if you're not aware of the best practices, it can just cost you so much that you will be unable to do a lot of experiments. And model degradation is also avoided because if you're constantly testing and doing the continuous integration of new features, you are aware that, okay, how these model is performing over time. So we are moving towards our final chapter, chapter three. I think I am also at time. So chapter three is the deployment part or putting the entire workflow into production settings. So when we talk about deployment, and from a model which is built and putting it into a production setting, there are still a lot of work to do. And this is what, I mean, not entirely, but some of these strategies are being used uh, right from a model to its production. So it includes MLOps foundations. MLOps is, as I was discussing earlier, it stands for Machine Learning Operations Foundations. So that includes version controls, CI/CD pipelines, which is continuous integration and continuous deployment pipelines. Containerization is something which is really useful. So that you can uh, pass on your end-to-end entire environment for testing, or you can share it with someone who wants to run your own code and use your data set for end-to-end analysis. These containers are also considered as the sandbox environment these days, and uh, I am not very much. I didn't get a chance to dig deeper into this, but the hyperscalers and these packs are getting widely used in this domain as of now. So then definitely there is continuous monitoring strategies when your model is deployed into production. We need to have a continuous monitoring and rollback strategies, which we can have. I'm not going into all of these, but these are some of the best practices tools and industry tools which are available. I'm happy to say that there is most of the tools which we are discussing for these foundations and tasks which are required for deployment are very much tested, and the community behind that is very much active. Uh, then we come to the data ops and pipeline management. So similar to ML ops, data ops is also important. And that's what we discussed today because in your AI ready workflows or in AI ready preparation, if you're following these end-to-end practices, your work will become very easy and you don't have to touch the source or raw data again and again. So your source and raw data is stored somewhere. You are just processing it in a pipeline and workflow and using it in your end-to-end system analysis. So for this as well, there are some tools which are very much used, like Airflow. Apache Airflow is a tool which is widely used, and we all are aware of Stack, Raster.io, Stack tools, and how these can be used. The third part too is the system testing and validation part. So for doing stress testing and for deploying any of these models, we need to do stress testing. We need to do robustness evaluation as well. So for this also we have some tools which are available, like the PyTest or hypothesis-based framework. With more and more automation coming in, the human in the loop setting becomes very important for validation, the human validation part. And this also includes the active learning based tools where we can actively update the model while we are doing the testing. Since I was talking about inference optimization, so once your model is ready, you need to do the model compression, batching mechanism for inferencing, parallel pipelines, and also deploying it to a cloud-based service so that you can scale it up. Uh, Hundreds and thousands of users can run it at the same time without failing the system. So for this, you have auto scaling tools like Kubernetes, Kafka, or also the acceleration runtime like Onyx and TensorRT, all these things. And last but not the least, for governance and accountability, we have model cards, we have access control, and for logging mechanism, we have other tools like for the fairness and explainability part, or how to save your secrets in GitHub scripts and your coding pipelines. You cannot just provide your cloud-based secrets in the code. So we have AWS services which can be used. And for cost benefit analysis, which is becoming pretty common these days, since the model development and data curation takes a lot of money and resources. So cost benefit analysis for each of the model development has become important for governance practices. And yeah, moving towards final section. So I'll quickly show one end-to-end workflow, uh, which is not focusing on how to develop a new model or what kind of model.
Sir,
Sorry. Oh, I think it was just
So
a
you can carry on.
comment.
Yes,
Yeah,
yes.
yeah. Thank you. So,
बोलो
yeah, I'll not focus on model development, but I'll show how to do an end-to-end AI ready workflow in this one. So I'll share my screen again. So is the screen visible?
Yes,
Yes, sir. Yes, sir. We can see this.
Okay, so this is the tutorial for GeoCroissant, which I was discussing, and uh, we are about to launch this. I can, if you're interested in this activity, please reach out to me after the session or anytime. In this, what we do is, so we can just install it, the pip using pip install command, and we'll be looking at a HLS burn scar example. So burn scar detection is a binary segmentation example, you can say, where you detect the burn scars given a satellite imagery with either a burn scar or a non-burn scar region. So in a conventional setting, what you will do is you will download this HLS burn scar dataset, which is like you have this is a zip file, but anyways, it's like you have image files and the associated mask which you will use for training the model. And these masks are binary masks, like explaining what could be a burn scar and what could be a non-burn scar region in that particular image. So it's a pixel to pixel mapping. In this tutorial, we are not going to do the conventional thing, but we are just going, and I'm just going through the notebook because we don't have time to run it, but it's available online. You can run it in your own time. And I would recommend that once this GeoCroissant workflow is out in the public, try to do all of your workflows or processing which you do in this way so that you have end-to-end right from the source data to the final model development. So what we can do is with GeoCroissant, we also have tooling around it. You can run it and it will take these files from Hugging Face or anywhere it is available, you need to define a bit of metadata here. So metadata as in what are the files which you have, what kind of data set it is, what is the alternate name. So these details, if you can provide, it will generate a croissant.json file for you, and that looks like this. So this entire file which we are looking at currently, the raw JSON file, it has entire metadata related to the HLS Banskar dataset. You can also see that it shows when the date was published, shows the license for using the images, what is the bounding box which is used for the analysis of this, temporal extent of the dataset, start date, end date, spatial resolution, which is 30-meter coordinate reference system. Then it also mentions what is the ML task this was used for. So you use it for semantic segmentation. It's a multi-class classification problem. The metric used is F1 score and all these things. Application domain is environmental monitoring. And then you have sensor characteristics like this. And finally, if I go towards the end, it also shows which uh, data biases you might have. So something like this can only work from 2018 to 2021 timeframe. Or this data set is only useful for contiguous United States or the CONUS region. It also mentions the class imbalance part. For example, 88% not burned, 11% burn scar, like this. So with this, now you can move on to the next step, which is you can validate the croissant file. After the validation is done, you can, here I'm just showing the same thing. It can also show what kind of files are there for training and annotation. Okay, once that is done, we can visualize a particular training sample directly from the JSON file using these. So this is not only metadata, but it also stores the data values. And as you can see, like this is the image in RGB and this is the annotation mask. So even if you are running your entire machine learning workflow, at any point of time, you have the facility to look into a particular data sample. And then you can run your own data analysis or data science checks. Like, okay, if the mean value in this entire image is more than the natural illumination, so it means that there is an outlier and we need to remove that pixel from training. Because if outliers are trained, the model will give outlier results as well. So this is more of a data centric AI part where you focus more on data and keep improving on it. Then you can pass it on to load as a data loader. You can build a PyTorch dataset, which we usually do from our conventional machine learning practice when the dataset is downloaded. You can create a batch, you can create a data loader, and then finally you can define a unit architecture and run it in an end-to-end setting. This is how we have just shown training the unit architecture for 5 epochs. Once it is trained, you can print the model, and again, you can use it for inferencing. So you can just use it for inferencing and get the accuracy. There is one more step after this, which will be hosting it publicly and doing the governance part of it, doing the MLOps part of it, doing the scaling so that you host it on cloud, and a lot of users can run it end to end. But from an end-to-end Geo-AI workflow and incorporating data and model workflows, this is how a typical pipeline could be. When we go to deployment part, that's the third step which we were discussing that I'm not showing right now. So yeah, I encourage you all to look into this. There are some more notebooks in this. I'll share the links later on once after the session. And yes, with this, I am at time, and thank you very much for patiently listening to me. It's an honor to talk to you all, and I'm very happy to know about your projects, what you're working on, any type of collaborative work we can do. You can reach out to me on these emails, and thank you for the invitation as well to the organizers.
Thank you, sir. So, actually, there is a question from a participant in the,
Yeah,
yeah, so the question is,
sure. Please.
can
Okay.
I, yeah. So you mentioned some tools for deployment. How can we choose the tools based on applications of spatial data?
Oh, yeah, this is a tricky question because when we have choices, it becomes difficult for us which one to choose. But I would say all of these tools are backed by community. I can give my preferences. So Git, LFS, DVC. Uh, I cannot even give my preferences. I've used all of these mostly in different projects. So I think it ultimately depends on what kind of team it is working on. But Fast API Podman is something which I've used a lot. Argo CD is something which we are using these days. And it ultimately depends on what you can work on and what the team can understand quickly. So, yeah, I know this is a very generic answer, but I'm sorry. Uh, so, one point, sorry, before I move on to the next question, one point which I would emphasize here is it is good to select tools which have community support and which are open source, so that you can reach out to community at any point of time. And I have been helped a lot from these questions, be it any of the open source development. So that way it helps you in using tools for the deployment practices.
Dear participants, the floor is open for the question, so you can raise your hands or post it in the chat box. Yeah, we have some participants raising. Yes, Deepali ma'am, you can go ahead.
Hello.
Yes.
Hello, sir.
Yeah,
Hi.
yeah, yes, Madhura ma'am, yeah.
Yeah. Sir, actually, I'm also trying to build image, satellite image forgery section. So you were talking about the croissant. So can you just elaborate how this can help me in my data set building?
Uh, I missed the first part, ma'am. You mentioned you are working on a satellite image analysis problem.
Satellite image forgery.
Okay, so Croissant is the standard for storing metadata along with your dataset. I can forward the link to specification and also the paper which came out last year. It explains most of the things in detail, but whenever you are using Croissant or such standards, you can kind of be aware that you are following responsible AI practices. And nowadays and going forward, there will be strict uh, guidelines to follow responsible AI practices because most of these applications are high stakes application. And if we are not able to see or define where the issue is coming from, that could be a problem. Coming to the question, how Croissant can help or GeoCroissant can help, in modern data workflow practices, we are trying to reduce the manual workflows as much as possible. So if you have a data set which is sitting somewhere or which is hosted somewhere, you can directly interact with that data from your client system or from your client laptop system. You don't have to download the data or bring data to you. Rather, you can take your workflows to the data and you just have to keep on updating the workflow. You can do it at a scale. So with Stack or Croissant, this is something an advantage which we have found out because the dataset scale with which we work on or the entire Earth data set which is there, it becomes very difficult for us to keep a copy of it, and it is not feasible at all to keep a copy of it and do the processing. So it's better to like get the data which we need for our processing on the fly access and then do the analysis. So in that way, croissant and geo-croissant can help a lot.
So we have a question from a participant. Can we choose another tool for JSON?
Uh, yeah, I think there is JSON is just a file format for representation because it gives you a it gives structure to unstructured data sets. So I think that's why Croissant was or GeoCroissant is using JSON or JSON LD at the backend. The other advantage of using JSON LD or JSON is it is very easily uh, transformable to graph-based approaches. So all of the graph-based processing and graph-based analysis, or the semantic web technologies, which we also have in geospatial domain. So those becomes easy. You can use GeoSparkle-based querying over these graph data structures. So I think that's a major reason why people are using JSON LD and JSON. But yeah, you can use other file formats as well. There is no such hard rule. The standardization uses JSON LD. That's what I wanted to emphasize.
Dear participants, any other questions? Yeah, Deepali ma'am has raised hand. Yes, ma'am, you can unmute yourself and you can ask your question.
Hello.
Yeah, you're audible. You can.
Yeah,
Huh.
I can hear you.
Sir, I just want to know what challenges do you face while working with the real-time or big data or heterogeneous data or temporal gaps with remote sensing data or satellite data?
Oh, we face a lot of challenges. So and we face challenges at all levels. So as I was mentioning, and the one example where when I presented the NISAR data volume was because with each project or each new data set coming in, we all are aware of it as well. New challenges come in. So, for example, when HLS data and all these data sets were used, the data volume was not so big. So it was still feasible to work on those. But with petabytes volumes of data, you cannot even expect a single copy to be made for 5 days or 10 days on any of the user because you have to pay for it. Even the input output operation will cost a lot of money. Uh, so with that, now the processing or data workflows have changed from what we were doing earlier. Now the focus is more on doing on-the-fly processing. So develop algorithms only which can be useful for you for a particular region, and you can do it in real time. You can extract that particular bounding box. Uh, to do that, the original data source should be in that format as well. It should be easy to chunk from a big chunk, like what we have been seeing in data cubes and ZAR-based formats. So this is one challenge which typically is there in data uh, curation perspective. From the data management side, again, since the volume is big, when I'm talking about sharing my data set with someone so that they can use the same algorithm and claim that my results are consistent for review perspective or reproducibility perspective, those are challenges which are there. So we need smart practices to do this sharing and reproducibility in a good format or good way. Then infrastructure is a big challenge, which also brings in the scaling and modeling perspective. So to model or to develop foundation models or even any model at such scale, it will require a lot of GPU based resources. So those challenges are there. And on a day-to-day perspective, I think the biggest challenge which we face is if there is a tool or a platform which we use or we are professing to use comes across with a lot of failures and issues, and you have to address those. So that's from the infrastructure part as well. And yeah, combining all of these, it becomes a user-centric data science these days. Uh, so yeah, I think challenges are there at all levels.
Thank you, sir.
Thank you, ma'am.
So there's a question from a participant. Is there any techniques used for validating Croissant metadata?
Yeah, that's a good question. Thank you. So we have a croissant validator as well. For geospatial one, we don't have a validator as of now. We are working on it. Uh, since croissant is also a standard format for all the NeurIPS dataset and benchmark track papers. So if you are not aware, NeurIPS is a top tier AI conference, which stands for Neural Information Processing Systems Conference. It's next week in December in San Diego. So for they have a specific track for dataset and benchmark. And if you're working on any dataset and benchmarking related work, you can submit your work there. And they have Croissant as a standard for datasets. So if you are submitting to that conference, you will have to use Croissant standard. And for that purpose as well, we are developing a validator which people can directly use before their submission.
Good evening, sir. I like to ask one question.
Sure, please go ahead.
Sir, in one of the FDP which is attended by me, in that FDP, one of the speaker told that you will not get that much data which is available with our neighbor country. Means minute details cannot be given by that ISRO open source software like Bhuvan and Vedas, which is not even authenticate, but you can trust on that data, which is available by the public platform by our neighbor country. And I expected that you can understand the when I use the word as a neighbor country. I don't want to take the name of that country also.
Mm-hmm.
So I like to
Sorry,
ask
ma'am,
means that
what's your
minute
question?
details is available with that data and which is openly available.
Mm-hmm.
Because already I work on that ISRO and Vedas and one open source data, na? So which is available public domain, and definitely they are giving the very good data for all the details like NDVI, LULC, surface temperature, and all these things. And I work on that. But this statement means I not understand that. While our that particular public domain data is available freely, so how that particular statement can be given? And no, my question is that is it is true? It is not घुमा फिरा के पूछना है कि is it is true कि that our minute details is available with the neighbor country by using that geospatial data.
I am sorry, I don't have any solid answer to this question. Uh, it would be better to reach out to the speaker who claimed this. I don't have any solid answer or proof for
Sir, I understand.
to
After
approve
not
this.
giving the answer of this question, I got the answer. And after that, there is some modification given by that speaker also while referring that particular statement key our geospatial data from our country. Because, okay, what is your remark about the ISRO's open source software like Vedas and Bhuvan? Is it
Uh,
is
I
easily available because I was finding for a Junnar in Maharashtra in Pune district there is a one place which is called as a Junnar, and I need that data around 2012 to 2020, that 20 to 25, but that particular data is given on request only.
Yeah, ma'am, I haven't used the system or software which you are mentioning, so it would be very difficult for me to
Okay.
comment on that. But I can uh, just say that please reach out to the relevant team. I think they would be the best in helping it. Uh, if there is anything openly available
Okay,
or
sir.
open source
Okay, okay.
available in open source, I think that is they'll be able to help.
Thank you, sir.
Yeah, thank you for your question.
So there's one more question from a participant. How do pre-trained or foundation models contribute to efficiency when training Geo-AI systems?
Uh, it's again a very good question. And foundation models with pre-trained features, they are assumed to be more efficient because they see more data which goes into the modeling. So more information is available from more years and or more data set, which gives you a bigger feature set which can be used for generating your analysis. I will not say that it's all the foundation model based applications are state of the art or they claim state of the art results. But at least let's just understand that earlier, if we are getting a feature set which was small or over only the training data which we are using, now we can use a feature set which is more representative and can be passed on with different applications. So that's how foundation models help. And this is same for, let's say, foundation model in vision domain or foundation model in language domain.
Thank you, sir. There's one more question from another participant. Can we use geocroissant for deforestation detection project?
Yes, if you have a data set for deforestation detection, you can definitely use Geo-AI. It's project agnostic, and you only need a data set to use the Geo-AI tools.
Thank you, sir. Dear participants, anybody else here for the question? You can unmute yourself, you can raise your hands or post it in the chat. Sir, there's one more question
One more question.
from the participant. Whether this croissant useful for high quality drone images in military applications?
Uh, yeah, again, as I said, it is application agnostic. So it's a way to define your metadata and dataset. So you can use any images and for any applications. It might happen that some of the attributes are not directly relevant to your drone images, but in that case, you can use the custom or variable properties. So those can be used for defining the metadata.
Thank you, sir, for your answer.
Yeah, I guess there are no further questions in the chat box, sir. So
Great,
it
we
was
made
a
it. Thank
very,
you very
very
much.
nice session, sir. I mean, we got a thorough knowledge. I mean, just knowing the things and having a look at it in so much of depth, it's really helpful, sir. And definitely we'll be
Thank you.
trying the geocroissant once it is out. Thank you. Thanks a lot, sir.
Thank you very
Over
much
to
for
you,
the
Mr.
invitation.
Lava.
Yeah. Sir, on behalf of our institute, AP Shah Institute of Technology, and even the organizing committee, the Department of Data Science, and all the participants, I extend our sincere gratitude for delivering such a comprehensive, interesting, and enlightening session. And the journey you took us to the three chapters from GIS data pre-processing to Geo AI models, and then you took us to the deployment and you have introduced us to GeoCroissant. Like that is a wonderful part of this entire session, the great takeaway we got today, sir. So thank you so much. Your expertise and the practical perspective have added tremendous value to our learning. So thank you for sharing your time, experience, and knowledge with us today. We are deeply honored, and really, it's a great privilege to have you with us today, sir. Thank you so much.
Thank you for your kind words, ma'am. Thank you for everyone to join patiently at this time of our, and I wish you all the best. And let's get connected again.
Dear participants, so as we Yeah, dear participants, so the feedback link is there. It's already posted. So kindly post your fill the feedback links, okay, and which will be considered for the particular session, and also it will be considered as your attendance. And yeah, we also thank all the participants because it's a sincere gratitude to all the participants for attending and engaging in today's session. Your consistent presence and the thoughtful involvement reflect your commitment to learning and professional growth. Thank you for making this session very meaningful. And yeah, so again tomorrow we will meet, and a humble request to join a 5 minutes prayer so that we can conduct the session very smoothly. Thank you so much.